My name is Omalola Abdullah and you're welcome to my YouTube channel. In this YouTube channel, we learn how to go in physics, learn about physics and diversify in physics calculations. And today we will be talking about what we call motion. And that is one of the very important topic you need to learn in physics. And what is motion? Motion is very simple. In physics, motion is just something that is related with time. So what do I mean? We already know motion is the change of position of a body. But in physics, motion is the change of position of a body with time. Which means before any motion can happen, there must be a change in the position of a particular body. Be it a car, be it a person, be it an object with time. So now we'll be talking about type of motion. We have different kind of type of motion in which you have my random motion, you have my linear motion, you have my oscillatory motion, and you also have rotational motion. So we'll be taking it one by one. So the first one is my random motion. What is random motion? This is the type of motion that moves irregularly. What do I mean? This type of motion doesn't have direction. Let's take an example as a look of smoke. A smoke doesn't have a direction, and a particle of smoke might go this way, the other might go this way. So that is random motion. It doesn't have a particular place that this is where I'm going. It just moves randomly. And we have gases too. That is random motion. Then we move to the second one, which is linear motion. What is linear motion? Linear motion is the type of motion that moves from a particular point to another particular point. That is example, a motion of a moving car that moves from point A to point B, from a particular place to another particular place. That is linear motion. And the next one, we have my rotational motion. So what is rotational motion? We already know from the word rotation. Rotation means something that moves in a circular aspect, that is, that moves around its axis. So rotational motion is just the type of motion that moves around its axis, that move in a circular path. So example of this, to gain more clarity, is a movement of a fan blade. Our fan blade, when it is on, it moves in a rotational motion. We also have another one. We all have moving car. The tire of a moving car, it also moves in a rotational motion. And the last one I have is my oscillatory motion. What is oscillatory motion? This is the type of motion that moves to and fro. It moves from this to this to this. Example, a typical example of this is a simple pendulum. So once we know this, is that this clarification of motion and the type of motion. So now, before we move to the calculation of physics, calculation of motion, it is very important we know some parameters of motion. We have distance, we have velocity, we have displacement, and we have acceleration. So now I'll be defining this one after the other. So the first one is my distance. What is distance? Distance is the change of the position of a body with time. And we have displacement. Displacement is the rate of change of distance with time, but have specific direction. So in these two definitions, we already know that one is a scalar quantity and one is a vector quantity. Distance is a scalar quantity, it has no direction, while displacement is a vector quantity. So next we move to speed. So speed is the rate of change of distance with time. So speed is equal to s all over t, in which s is our distance and t is our time. So next we have acceleration. And what is acceleration? Acceleration is the rate of change of velocity with time. So the formula for acceleration is a equal to v minus u all over t, in which v is my final velocity and u is my initial velocity. And why do we have final velocity and we have initial velocity? We say it's the rate of change of velocity with time. So there must be where it started from, which is initial velocity, and where it ended, which is final velocity. So in knowing these parameters, we need to diverse into the equation of motion. So equation of motion is three. We'll be looking about three equation of motion, and I'll be listing it out. The first one is v is equal to u plus at, and the second one is s equal to ut plus half at square, while the third one is v square equal to u square plus 2as. So I'll be listing out what it means one after the other. In my first equation, I say v equal to u plus at, in which my v is my velocity in meter per second. My u is my initial velocity in meter per second. My a is my acceleration in meter per second square. And my t is my time taken in seconds. Then I have my next one, which is s equal to ut plus half at square, in which my s is my distance and my u is my initial velocity, my t is my time as listed earlier, and I have my next one, which is v square equal to u square plus 2as, and it also takes the formation of the other listed above. So there are some important things to notice when solving the equation of motion, which are three. I'll be listing them out now. So the first one is that whenever you are solving an equation of motion problem, you have to keep it in mind that any motion, the body accelerate from rest, which means when the body starts from rest, its initial velocity will be zero. Which means when the body starts from rest, the u equal to 0. Then I move to my second one. When a body comes to rest, its final velocity is equal to 0. Which means whenever you are solving and you come across a body comes to rest at a particular distance, which means your final velocity is already 0. And my third one is when the body is constant, that is, a body is not moving, then acceleration is definitely equal to 0. In some way, we have learned about the definition of motion, we have learned about the type of motion, and we taught the equations of motion. So what is motion? Motion is a change of position of the body inside. We learned the type of motion, which are random motion, linear motion, oscillatory motion, and we also have rotational motion. And we have equation of motion. We learn about the three types, which are v equal to u plus at, s equal to ut plus half at square, and v square is equal to u square plus 2as, in which my v is my final velocity, my u is my initial velocity, my s is my distance, and my t is my time. And don't forget, when a body starts from rest, its initial velocity is equal to 0, and when a body comes to rest, its final velocity is equal to 0. And when a body is constant and not moving, its acceleration equal to 0.